Stoichiometric calculation. Stoichiometry means the relative quantity or ratio of substances in a reaction. So it doesn't show you the actual amount, it's just the relative quantity or just the ratio in a chemical reaction. So for example, here you have hydrocarbon and oxygen, and it produces carbon dioxide and water. So from this chemical equation, you can say that 1 mole of hydrocarbon reacts with 5 mole of oxygen to produce 3 mole of carbon dioxide and 4 mole of water. This is not the actual number of mole, it's just the ratio or the relative quantity. So from this equation, you can say 1 mole of hydrocarbon produces 3 mole of carbon dioxide, 1 mole of this hydrocarbon produces 4 mole of water, and then 5 mole of oxygen produces 3 mole of carbon dioxide, and so on. For example, you have a propane reacts with oxygen, it's a combustion of propane. How many moles of water are produced when 10 mole of oxygen are consumed? So 10 mole of oxygen is the actual number of mole of oxygen. From this balanced chemical equation, you can say that 1 mole of propane reacts with 5 mole of oxygen. From the chemical equation, it's not the actual number of mole, it's just the ratio. The actual number of mole of oxygen is 10 mole. So 5 mole of oxygen, this is the ratio from the chemical equation. So 5 mole of oxygen produces 4 mole of water. Okay, from the chemical equation, 5 mole oxygen produces 4 mole of water. The actual number of mole, you have 10 mole of oxygen. So you can get 8 mole of water if you have 10 mole of oxygen. Next, methanol burns in air according to the equation. 2 mole of methanol reacts with 3 mole of oxygen to produce 2 mole of carbon dioxide and 4 mole of water. If 209 grams of methanol are used up in the combustion, what is the mass of water produced? So now we are going to compare the methanol and water. So from the equation, we have 2 mole of methanol equivalent to 4 mole of water. So the number of mole, the actual number of mole of ethanol, not 2 mole. 2 mole is just from the ratio, from the chemical equation. So the actual number of mole, you can find it from the mass of methanol. Mass of methanol divided by the molar mass. This is the actual number of mole of methanol. So when 2 mole of methanol produces 4 mole of water, 6.531 mole of methanol produces 13.063 mole of water. So you just compare 2 mole methanol produces 4 mole water, 6.5313 mole produces this amount of water. So the question asks the mass of water. You already have the number of mole of water, so you just times the number of mole of water times with molar mass of water, and you'll get the mass of water. Next example. How many grams of phosphorus with 35.5 liters of oxygen at standard temperature and pressure to form tetraphosphorus decaoxide. This is the chemical equation. Make sure it's balanced first. Then you can compare the stoichiometry. So, first, find the number of mole of oxygen gas. At standard temperature and pressure, 22.4 liter produces by 1 mole of oxygen. So number of mole, if you have 35.5 liter, the number of mole of oxygen is 1.5848 mole oxygen. This is the number of mole of oxygen produced. Next, from the equation, you already have the number of mole of oxygen. From the equation, 1 mole of P4 reacts with 5 mole of oxygen. But now you don't have 5 mole. The actual number of oxygen is not 5. The actual number of mole of oxygen is 1.5848 mole, needs 0.3169 mole of P4. When you already have the number of mole of phosphorus, you can get the mass of phosphorus by multiplying the number of mole of phosphorus with the molar mass of phosphorus. And the final answer is 39.3 gram phosphorus.